Continuing on in our random assortment of facts from pre-calc that you need to know, we can calculate the midpoint or the distance between any 2 points. So I've drawn up here 2 points, 0.11 and 5,4. To calculate the midpoint, it shouldn't surprise you that the midpoint of the segment connecting these 2 points is just going to be the place that's in the middle both horizontally and vertically. So we can see is that if we draw in the horizontal part of the distance between them and the vertical part, what we would expect is that if we find the midpoint of the vertical part and the midpoint of the horizontal part and put them together into 2 points, into one single point, two parts of an xy coordinate, we're going to get the midpoint of the line segment right here. So in fact, what we do is we just average the x and y, the x parts, and then average the y parts and put them together in a point. So the midpoint is going to equal the average of the x parts, which is going to be 1 plus 5 over 2, and the average of the y parts, which is 1 plus 4 over 2. And that just gives us 1 and 5 is 6, so that just gives us the point 3, 5 halves. It's the midpoint. In general, for the point x1, y1, and x2, y2, the midpoint is just x1 plus x2 over 2, comma, y1 plus y2 over 2. In other words, the average of the x parts and the average of the y parts. And that's the midpoint formula. To find the distance between the 2 points, the thing to recognize, which is already suggested by this diagram, is that the length of the segment joining the two red points is actually the hypotenuse of a right triangle. So we can find the distance between them using the Pythagorean theorem. Recall the Pythagorean theorem is just a squared plus b squared equals c squared, where a and b are the lengths of the legs of the triangle, and c is the length of the hypotenuse. So in this case, what we can see is that the horizontal distance of this leg is just going to be one of the x coordinates, one of the x part, the horizontal distance is going to be just the difference between the two x parts of the coordinates, and the vertical distance will be the distance between the two y parts. So this is going to be 5 minus 1 equals 4, and this is going to be 4 minus 1 equals 3. So what we can see is that the length of this hypotenuse is just going to be the square root of 4 squared plus 3 squared. We solve for that, get c equals the square root of 16 plus 9, which is the square root of 25, which is 5. If you're paying attention, you may have noticed that actually if I write out a squared plus b squared plus c squared, I would technically get both plus and minus 5 as a solution. But since we're looking for a distance, and distances are always positive numbers, we can disregard the negative solution. In general, we can write the distance between any 2 points, x1, y1, and x2, y2, is simply equal to the square root of the horizontal distance, which is x2 minus x1 squared, and the square of the vertical distance, which is y2 minus y1. And of course, since we're squaring these differences, it doesn't matter which order we do them in. It's possible that x2 minus x1 comes out itself to a negative number, but it's not going to matter because we're going to square it anyway and get positive numbers. So even if one minus the other ends up negative, once we square it, you always get positive. So there's the distance formula for any 2 points, x1, y1, and x2, y2.